Thank you. All right, good afternoon. We're going to do 9.2 translations. After this lesson, you should be able to successfully translate a figure and describe the transformation. A translation is a transformation which slides a figure the same direction or distance and the same direction. Translations represent a slide of the figure. I know you got to fill in those words, so I'll pause a second. A translation maps each point to its image along a vector called the translation vector. Now, vectors are written in similarly to points, but they use pointy brackets on them. And this is, it's kind of like X and Y. The first number tells you how to go left and right, and the second number tells you how to go up or down. So I just did it in symbols, but there's always there's a comma between. They're just like a point, but the brackets are pointy, and that's a vector. So we're going to draw the translation of the figure along the translation vector. We need to draw a line through each vertex parallel to vector U. You measure the length of the vector to the tail. We're going to need a ruler. And we locate the image of each point by marking off its distance along the line through the vertex. You start at the vertex, move in the same direction as the vector. So I know you just heard nothing from what I just said probably. So let's look at what it means in a picture. So this is on your paper. You're not doing this physically, and I am going to stop in a minute and have you guys get a ruler, but not right now. Hold on a second. So what happened when they did this figure, this is translated. The prime notation is the translated triangle ABC. It went in this direction. So what they did was measured from the beginning here to the tip of the vector, and then they did the same length for all of those vertices in the same direction and made the picture. So you have to actually go parallel. We're going to try to do more that are going this way or this way because it'll be easier for us than doing these slanted ones. So the point would be we're going to do this one. I'm going to flip over to my document camera because I'm going to show you how to do this. So would someone in the front, I'm pausing this. We need to measure this vector. It's going straight up. So we're going to take all these corners and we're going to measure this distance and we're going to go in that direction. So it's going to slide up. So I'd like you to take your ruler, of course, and measure how big that vector is. I think I'm going to use the centimeter side. I got 2 centimeters. You with me? I'll use the tiny marks, please. So it's 2 centimeters to just go to each corner so that you can see them. And we're going to draw, you can even make a line 2 centimeters long. Or you could just put a dot there. It's up to you. And we're going in the same direction as the vector, so we're going straight up. Okay, do that with each corner. And then connect those points. And if you do draw all the lines, it makes a 3D object. I didn't do this very straight. Okay. Then we'll look at number 2. Does anybody still need some time for that one? Okay. Okay, now we're going to go measure this one. But I'm going to have to turn my ruler, or you have to turn it upside down. Okay, so I'm measuring, and I got about 3.5 centimeters. Let's go with 3.5. All right, so go up to the corner F. Don't cover it up with your ruler. And we're just going left, straight left, so try to keep horizontal with your paper. And that would be F prime. We need to label these now. Do the same to D. You know what? I turn my light on. Maybe that'll be a little better. So I got to do the same at D. Ooh. It's kind of on the same line. So that's going to be D prime. And E. E prime. And then connect the dots. Kind of already got two connected because they were on the same line. And that one doesn't look as cool as the first one, but oh well. Does yours look like that? I'm sorry? Sorry, you have a headache? All right, I'm going to switch back to my Smart notebook because that'll look better than this. Pardon? You don't have to. That's it. You mean the ones that you can do first? You don't have to even draw them. You can just make dots if you want, and then you don't, or you can have the lines. I don't really care if you keep the lines or not. All right, now we're going to do it in the coordinate plane. So this is the vector, and it says 6, -2. So we're going to translate the cat, C-A-T, by the vector 6, -2. What that means is 6 units to the right. The first number is right or left. The second number is up or down, and 2 units down. So you can just physically do it by pointing. Pardon? No. 1, 2, 3, 4, 5, 6, down 2. There's your C prime. A goes 1, 2, 3, 4, 5, 6, down 2. A prime. You thought it was going to go off. And T, 1, 2, 3, 4, 5, 6, down 2. T prime. Then we just grab our straight edge, or we have a fancy tool like I do, and make the segments. Cat's been translated 6, -2 by the vector 6, -2. Or it's like it slid. Do you see why we call it a slide? Looks like it slid over. Okay. Reflections we're calling a flip. So we're on our second transformation. The next problem has triangle TRE with vertices -2, -1, okay, etc. We want to do the vector -2, -1, 2, which means, oh, I got to wait for you guys to flip your page. Don't I? All right, that vector would mean translate 1 unit to the left and 2 units up. Okay, so first, another way to look at it is you take all your points, the x's you subtract 1, the y's you add 2. Okay, so let's plot the original triangle first of all. At -2, -1, put point R. negative 2, point E. Oh, my E's have been weird lately. T is at 3, negative 1. And then I'm going to go ahead and draw the triangle. Next, I'm going to translate all these points, left 1 and up 2. So I'm just going to do it, and then I'm going to fill in all those little blanks. Left 1, up 2. So see how I didn't connect the corners? You could, and then it would look 3D. But we're going to name the points. Oh, don't forget the prime notation. They should have little, they should be the same letters, but they have a little hash mark or little dash up at the top. Slash, whatever you want to call it. Now, what's this indicating here is that we could have done this. We could have subtracted 1 and added 2 to the x component, which would give us negative 3. Negative 1 plus 2 is 1. And then I check r prime is at negative 3, 1. E prime is at negative 3, 4. If you subtract 1 from negative 2, you get negative 3. If you add 2 to 2, you get 4. So that's the same location. And T prime, if you subtract 1 and add 2, you would get 2, 1. And that is where T prime is, 2, 1. So we're done with that one. All right. Graph each figure and its image along the vector and graph carefully. Label your image points accurately. Quadrilateral, we got 4 letters, quad, 4 sides. T is at negative 3, negative 8. I'm going to need to slide this up, which is way down here. Negative 6, positive 3, U. Now here's why we write very carefully about your points. 0, 3 is don't go right or left, but go up 3. So that's right on the y-axis. And 3, 0 is on the x-axis. Okay, so they're different. Okay, I'm going to draw the figure. Now I'm going to think about the translation vector. It says 4, 5, which would mean right 4 and up 5. So I'm just going to do that to all my points. 1, 2, 3, 4, 1, 2, 3, 4, 5. U prime is way up top. And V prime is going to be up top too. 1, 2, 3, 4. 1, 2, 3, 4. There's V prime. When you're finished, your figure should look like mine. It will always stay the same shape and size, just slides to a new location. Okay, I can wait. If you guys need a little more time there on that. I know I went kind of fast because my drawing tool is a little faster than you moving around your ruler, right? And that didn't ask me to list the points, so I didn't do it. But that'd be like adding 4 to the x's and adding 5 to the y's. What? It does? Yours has, oh, it has to have them all like blanks for them? Oh, okay. So you need to have P prime, U prime. Or are they over on the side or something? Well, nobody mentioned that to me earlier. So I didn't even realize that because I didn't look. All right, so you've got a list U prime, T prime, V prime, and W prime. All right, you can either use the picture and name them from that, or you can say add 4 to -3, that would be 1. -8 plus 5 would be -3. And then I can check that 1, -3 is where my T is. That's supposed to be a U. U prime, add 4, -2, and 5, 8. V prime is at 4, 8. I added 4 to this and added 5 to that. If I add 4 to W, I'll get W prime is 7, 5. Is everything answered now on yours? Okay. Graph each figure and its image along the given vector. Graph very carefully. Label your image points accurately. Okay. QRS is a triangle. 2, 5 is one vertice. Label it Q. 7, 1 and -1, 2. Okay, so here's our original triangle. The vector is -3, 4, which would mean left 3, down 4. So I'm physically just doing it. 1, 2, 3, 1, 2, 3, 4. 1, 3, 1, 2. All right, and then connect those points. I think you're like translating. Do you have to list the points too? Okay. So does it start with Q and then R and then S? Q's at -1, 1, Q prime. R prime is at 4, -3. And S prime is at -4, -2. Any questions? Do you want me to wait a little bit? Okay. Now it says, well, they got this graph for us already. And then it says translate quad at the right, 2 units right and 3 units down. Away, to the right and down 3. And then I'll just label them with prime notation. Then oops, my Q is going to be in the way. If I connect them, should look just like the original, slid down and right. Okay, the vector, if it said 2 right, how could you write it in vector notation? What would 2 right, 3 down be? Yep, 2, negative 3. Okay, you need me to wait? You don't have those. This is their first problem, so now you get to practice. And I'm going to give you about 10 minutes, and then we're going to do some ISN. This is, we went from chapter 3 to 9 because we decided we wanted to go in that order. So we're doing transformations, then we're going back to chapter 4 and then 5. All right, page 2 in the ISN starts off just with a picture that discusses, this is like out of your textbook, that a reflection in a line maps a point to its image such that if the point is on the line, then the image and pre-image are the same point. If the point's not on the line, here's the illustration of one that's not on the line. A and A prime, the segment connecting, if the point does not lie on the line is perpendicular bisector of the segment joining the 2 points. What that's saying is this line right here gets bisected and it's at a right angle also on to the reflection line. There's a right angle right there. So you want to remember that if you connect the 2 points, the image and the pre-image points, that their line of reflection is the perpendicular bisector of that segment. Okay, so we're going to reflect ABC over line M. So we want to grab our ruler, and we haven't done a reflection since last week, so let me show you that you want to take your ruler. I'm just going to use one of my marks on my inches side, those long marks right here, where a whole inch is, I'm going to line up 2 on the line so that I have it at a right angle with the line. Okay, this is line M. And we'll label the top point A, bottom left B, bottom right C. We are going to reflect the triangle over the line by measuring how many marks from the 2 it is to get to point A. Gotta hold that ruler straight. Got to be lined up nice and straight so that it's at a right angle with line M. If you wish, you may even draw a line that goes from A to the other side. You don't have to, but you can. Now, I don't like, mine's not perfect because I didn't slide it up quite far enough. I didn't want to go exactly where I wanted it. You scooch it a tiny bit. You don't want to cover up point A. Right, I'll get it better. All right, now I want to go to this side the same distance. So I don't want to put the point here because I went too far. So I'm going to measure. I'm going to count how many tick marks it is. 1, 2, 3, 4, 5, 6, 7. Is it 8? Or is yours only a 6? Okay, my ruler is a little off from your ruler. You should be getting 6. I remember doing it physically on the paper. I'll tell you why. My ruler, if I grow it a little, yours is more like this, isn't it? 1, 2, 3, 4, 5, 6. Nope, still not big enough. One, 2, 3, 4, 5, 6. All right, I'm trying to get it so it matches yours. That's better, right? Okay, so yours looks about like mine now. All right, so I go to the other side. 1, 2, 3, 4, 5, 6. Same number of units. Oops, make a dot. And you can leave it on that line if you like. I'm going to get rid of that dot that doesn't belong there. I can erase the rest of that. All right, that's going to be A prime. And I know that took me forever. All right, now I got to do it to B and C. Now that I got my ruler about the right size. B and C are going to be on the same line because they are both straight away on the ruler. They're I'm going to measure where C is. 1, 2, 3, 4, 5, 6. Are you getting 6 away on that one too? So I'll make a dot on the other side at 6. And then the B point is a lot of little tiny segments. How many? That's a whole inch plus 1. So we'll go a whole inch plus 1 dot past the 3 on this side. Okay, so what I've got here is this one's, oh, sugar. There we go. Fix that. This is C prime, and this is B prime. And now I'm going to connect them. And there's my reflected triangle ABC. It's a lot easier when you do it on a grid, isn't it? Okay. So if we're going to go over the y-axis, we want to remind ourselves that the y-axis is the vertical axis right here. And I'm going to reflect over the y-axis. Did I go too fast? So from the y-axis, this first, oh, we got to get this thing labeled, ABC. So point A is 3 to the left of the line, so I'm going to make a dot 3 to the right of the y-axis and call that A prime. B is 1 left, so I go 1 right. And C is 2 to the left, so I go 2 to the right. And then I make that so much faster than doing the other way. Connect the dot. All right, and those points now we have reflected over the y-axis. Does anybody still need this page? Okay, now this is a generalization about how reflecting in the x and y axis. If you are reflecting over the x-axis, the y values change sign. Another way to think of it is multiply the y coordinates by -1. You will have this as a rule. It's just saying here to change the sign of y. And that's because when you go over the x-axis, which is highlighted here, and if you don't have that highlighted because you don't have color, then you might want to highlight the x-axis. So the point flops over the x-axis, that would change the y values depending on which direction you are going. Y-axis is the next one, and that's when you multiply the x coordinates by -1. Now we're going over that axis. That changes the sign of x. All right, reflecting a figure in the horizontal or vertical line. I want you to note that it's not time anywhere close to time to go, so quit packing up. X equals -4 is a vertical line. And that line, I want to highlight that line in that picture. The vertical line at x equals -4. You see how there's the origin, 0, 0, 1, 2, 3, 4. They drew this vertical line. Okay, and then they reflected that figure using that as where you count from. Okay, the pre-image is the original figure. That would be the one without the prime notation. This is called the pre-image. And the one that has the prime notation is the image. You're going to have to be able to identify that on a test. Which one is the image, which one's the pre-image? A line that says y equals is a horizontal line. This is the last one. Okay, and that's your line y equals 2 right here in this diagram. Please label that the top figure is the image of the pre-image is the bottom figure. The original figure is the pre-image. Okay, the only other thing I was going to do is color the image. All right. Timer timeout.